Okay, hello, let's give this a try, see if I can explain some of the terms that I've been using in the forum, such as gamut and color spaces and all of those sort of things, you know, profiles and why I bang on about paper and calibrations and all. What I'm going to do first of all, I'm going to open up a program I've got called ColorThink Pro. ColorThink Pro is a good program in that it enables me to visualize the profiles that I create for my printer. So first of all, I'm going to open up a 3D grapher, and what it shows, the grapher, is this color space, this grid I should say. What this grid is composed of the L axis, the vertical axis, which stands for luminosity, white at the top, black at the bottom. Then we've got two axes as well. We've got the A and the B axis, which is why it's called LAB, or lab color space. And the axes are the blue and the yellow axis, and the green and the red axis. So what we've got is green, red, and blue and yellow. Okay. Now these colors are every color that is possible can be described using this system. Just because a color though can be described using this system doesn't mean it can actually be seen. There's various devices such as monitors, printers, the human eye. All of these have got different abilities to project and see colors. So what we'll do first is have a look at the sRGB color space. Now the sRGB color space is a volume of color that most, well, to the best of my knowledge, all cameras can reproduce. So I'm going to show you what the sRGB color space actually looks like. So we're going to look from up top, and you can see it's got quite good width in green, so it can reproduce a fair bit of green, red and blue. And as we come down, it can also go all of those colors down to blacks. Okay. Essentially what you're looking at, the further from the center you are, you're talking about saturation. So highly saturated yellows, highly saturated reds and blues. That's what it is essentially. Now I'm going to open up AdobeRGB. And AdobeRGB is a color space which is a bit bigger. So you can see sRGB is completely covered by AdobeRGB. And AdobeRGB can display a lot more colors than can the sRGB color space. So in around the green, especially the pale greens and the yellows, look at how much extra color is available in AdobeRGB. For the third one, I'm going to turn on the ProPhoto color space, and the ProPhoto is a color space that I use myself. You can see it's absolutely huge. It's ginormous, and it completely engulfs AdobeRGB and sRGB. It's absolutely huge. So I'm going to turn on a wireframe for that. For the AdobeRGB, we'll go flat, but I'll bring the opacity down. So now you can see all three color spaces, the representation. The outer wireframe one is ProPhoto. This partially opaque one is AdobeRGB. and this solid one in board is sRGB. So have a look at the greens and the yellows, the capabilities of these color spaces. In the yellow, sRGB doesn't have much, has a bit more in Adobe, but there's a hell of a lot in ProPhoto. It's the same in these blues as you transition in between the greens and the blues. So just remember, all of this is related to saturation. The further you are from this point, the more saturated that color can be. So this is a highly saturated blue out here. So sRGB is just not able to saturate colors as much. Same as in the reds here, you just don't get the saturation in the colors. And in some images that you take, you do want highly saturated colors. Now, the problem with color spaces can rear its head when you go to a paper. When you want to print, prints rely on reflection of the light, and a monitor might have a contrast ratio of say 1000:1, so you can have them extremely bright and they'll go black, so a wide contrast ratio. But a paper is a low contrast medium. If you're lucky, you'll get 250:1 contrast ratio, so you've got to squeeze a hell of a lot of saturation and contrast down into a gamut. So I'll show you an image that I've got, and I'm going to drag it onto a window. So here's the image, and you've got oranges here, lots of browns, dark browns, all the way through here. These are very saturated colors. So this is the image I'm going to show you the color gamut of. So I'll just open, I'll come in here, that's the TIFF file. So while the program actually works out what colors are in those what colors are in that image, anything that's within that boundary, within that volume, can be printed and displayed fine. Anything which is outside is going to be an issue. So as you can see here now, all of these colors are outside the boundaries of the sRGB color space. So that means that essentially these colors don't exist in sRGB. You mightn't think that's much of an issue, but if your monitor is only capable of displaying sRGB, and quite a few monitors are not able to even display that, they'll have a smaller volume. When it comes to displaying these colors, what happens to them? Well, this is why it's a good idea to have a wide gamut display, which can show almost 100% of AdobeRGB. I'm going to turn on AdobeRGB now. Just wait for it to catch up. Now you can see some of those colors fit in a bit better, fit in that volume. So there's fewer colors outside that gamut. So there's still an issue going on, but not as many. Now that image is in ProPhotoRGB, so I'm going to turn that on now, and now you can see that all of those colors in that image fit inside that gamut. So I'm going to turn off ProPhoto a minute. I'll turn on the TIFF, sorry. I'm going to turn off all of these. I'm actually going to load a paper profile. This is the range of colors in this image. So you can see the oranges, blacks, these whites are up here, these oranges are around there, this orange is all around here, and these are saturated colors, don't forget. So what I'm going to do now is load up a paper profile. that I've created. I've got an i1 Pro 2. This is a calibrator by X-Rite. It's a high-end calibrator which will calibrate projectors, monitors, printers. It'll perform analysis on the software. It'll do a hell of a lot of work, and this is something that I think is important for my work especially. So I created a target, I've scanned it in, and I'm going to load this paper profile I've called JMP for John Murray Photography, Epson 3880, and the paper is Hahnemühle Photo Rag. This is a matte paper. So it's, some people don't like matte papers, but it's a matte art paper and it is absolutely gorgeous. It's a beautiful finish on it. I highly recommend it. It just doesn't have much of a gamut. So I'm going to load this profile up, and we'll see where these colours are actually able to fit inside the profile. So this is the volume of colour that paper can print. So you can see it doesn't go down to absolute black. It's not capable. It's a matte paper. Doesn't quite get on the whites. If we look above, it's got a reasonable range for the yellows, but we're more interested in the oranges and the browns. So there's a few colours that lay outside the capabilities of the paper. So how do we actually print these colours when they're outside the capabilities of the paper? There's something called rendering intent. Now, a rendering intent, you may see it if you print, and there's 4 options, but there's only 2 that we're concerned with as photographers. And those rendering intents are relative colorimetric and perceptual. Now, relative colorimetric will take these colours that are out of gamut and they will essentially just chop them off. So you'll end up with a smearing of colours, and if you've got a colour which is well out of gamut, this deep orangey colour, it will be chopped off to somewhere around that colour from there, if you understand what I'm saying. There's no computation to work out where it should be. It just gets chopped off to the surface of that volume. The other rendering intent, which will work well for this image, is the perceptual rendering intent. What it does, it grabs this particular colour and it pushes it into the surface, and all the colours around that surface will deform as well. If you could imagine a balloon, if you push it in with a thumb, the surface of the balloon distorts, and that enables colours next to each other to be adjusted as well. So this colour and that colour will all be pushed in, and it'll be sufficient deformation on the surface to keep the perceptual difference between adjacent colours. So instead of all of these colours being reduced to one colour on the surface, it'll be a perceptually different colour. Even so, in other words, it's not an accurate colour, but perceptually it is, because this is the accurate colour. So with that now, I hope that's illustrated some of the problems with gamuts and colour spaces. And just to finish off, I'm just going to show you again the ProPhotoRGB colour space, so you can see how small this particular paper profile is. Just before I finish off, I'm going to load one more paper profile up, and it's one that I quite like as well. It's put out by Ilford. It's a gold fibre silk. I find the paper a bit brittle in that it can scratch, but this paper is beautiful gamut and it's got quite a large volume. Now, this is the gamut of the paper, so I'll make that gamut a wireframe. So you can see the differences on those two papers. The wireframe is how much extra volume there is in the gamut, and as you can see, if we had an image with lots of these, instead of being oranges in greens, we'd be able to print okay. But with this paper we still have some colors which are out of spec, so we still need to take into consideration the rendering intents. But I'll turn the gold fiber silk color off. I hope that's given you a bit of an understanding of why in the photography learning forum I talk about calibration and profiles and color spaces and why it's important. My images are designed for print primarily, and so I need every bit of color that I can to transform it into the paper. Let me know what you think of this video. Any questions, just give me a heads up. Okay, catch ya. Bye bye.